So here's our project, the wireless elevator. This is the demonstration of how it works. It's going to be 4 states. The first state is ground, where the elevator doesn't move. The second state is 1, where the elevator goes up. The third state is 2, where the elevator continues to go up. And then the fourth state is shown by an LED. And then it resets and repeats those 4 states. Hi, I'm Elijah Shank.
I'm Elijah Williams.
I'm Mr. Georgiev.
And this is our wireless elevator. Hi, my name is Elijah Williams. So a brief overview of the elevator. It's supposed to be wireless. It's supposed to have a transmitting side and a receiver side. We're supposed to have 4 states, right? So we're supposed to have a ground floor, first floor, second floor, and then a 4th state. Our 4th state was just displayed on the LED. The ground floor wasn't supposed to move, and it was supposed to be moving on the 1st and 2nd states. This circuit starts with the power on circuit right here. It runs on a 9-volt battery. Next part of the circuit is this 555 timer. This acts as the clock for the different states of our elevator. Here, let me show you on the oscilloscope. As you can see, we had to create an astable clock. That's gonna create a square wave. So that's on, that's off, that's on, that's off. It's running at a frequency that's less than 1 hertz, and we have 3.8 volts peak to peak. So from this clock, we're running into a JK flip-flop to produce a counter. It's a binary counter that's counting from 0 to 4. The next step of the circuit is to go to a decoder. Decoder, we have to turn these 2 outputs into 4 states. So it's a 2 to 4 decoder. We also have to flip the highs that are coming out of the counter to lows, and that's what decoder is doing.
All right, my name's Elijah Shank, and we back in. Just like Elijah said, it's a 2 to 4 decoder that goes into an encoder. Now this encoder is special because it goes to the transmitter, which transmits our signal from this side of the circuit to our other circuit, the receiving end. But back to this side has our 3 7-segment displays. These 7-segment displays are special because they run off a low voltage, not a high voltage. They're active lows, and these signify ground floor, the 1st floor, and the 2nd floor.
My name is Mitko, and we're at the receiver side of the circuit. We have the signal that's being received over here. Then it goes to a decoder that decodes the signal. We also have the 7-segment display connected to it that indicate the floors. That's also connected to an inverter that takes the lows and turns them to highs, to a MOSFET that goes up to the motor. Back at the signal, we can see on the spectral analyzer, it's transmitting at 433 megahertz. This is being modulated from the transmitter and demodulated at the receiver.
So yes, this was our final project, the wireless elevator. We learned a lot of concepts, especially with the transmitter and receiving end. This was a very, very challenging project that took multiple hours in the labs, Sunday, Saturday. But at the end, it was a great learning experience. A lot of new things we worked with were the spectral analyzer and the oscilloscope. But it was also nice to have parts that we had used before, like MOSFETs, to get the motor working, and the 7-segment displays. It was a couple challenges throughout the way with our JK flip-flops and our 2-bit counter. We also had a couple issues with potentiometers leaving floating voltages. I also wanted to shout out Jabari and Mr. Lewis for opening the lab on the weekends so me and my group could really get this done. It was a great project, and we all had fun putting it together.